Hi, this is Ram from Crossmind Studio. Welcome back to another chapter of Geometry Node series, and this is fifth chapter. And today we are going to talk about the very basics of math nodes, the values, numbers, integers, and float values, vectors, and what all these terms mean. However, these are really basic concepts, and most of us have the knowledge of basic math, how it works in the real world. But in given interface and with the color information for these different socket types, trying to understand this could be a bit difficult for beginners. That is what we are going to do today. Do a very basic animation of this clock, which is completely made with this node network without any animation keys. Let's talk about math a bit. So usually when we're working in a 3D interface, we simply go to the edit mode. We try to shape things up by moving it around. We're not really dealing with numbers. So computer is doing a background work and recording all these numbers. But what we're doing is taking a visual call on this and trying to shape it up. And this is more of an artistic approach, all right? But when it comes to geometry nodes and when you're dealing with a procedural or parametric stuff, often you will be dealing with numbers. Let me just bring a simple object. We're not really going to do anything here, but just talk about a few things. So a simple value, a number. So let's say 4.9, 13.2, or any number which contains a decimal in the programming language or often in 3D packages, it's called a floating number. So what floating number means is it's simply any number which contains a decimal. A hair could be this dense, or a thing could be this tall, 3.4. Some ingredient could be 12.8 or something like that. When this becomes a round number, so let's say five candies or 10 people or 15 computers, anything which doesn't contain a decimal, that value is called an integer in this interface. But not all the time we are just dealing with simple numbers, and especially when we're dealing with 3D information, we have this X, Y, Z and degrees in different directions, or RGB when we are making colors. So when these numbers are combined, so let's say three numbers, so let's say if this was X and Y and Z, 10 in X direction, 15 in Y direction, and 20 in Z direction. So let's say 10 in X direction, 15 in Y direction, and 20 meters in Z direction. So not all the time these numbers are used individually. So often three float numbers when grouped together can describe position of an object or a rotation of an object in 3 dimension, or maybe a color like a XY RGB or something. In real world, usually we are using GPS coordinates. Those are also given in group of numbers. So a vector have 3 different float values, and 3 different float coming together can make a vector. And this one is represented with the blue color here. On a float number, you'll see this gray value, the gray color. And whenever you're dealing with a vector number, it will have these 3 inputs or outputs, and the vector input or output is going to be a blue color. All right. And why we are talking about all this is because often when you're doing some math in geometry node, when you changing a shape of an object or something, you can't really, at this moment, you can't really go to the edit mode and do this, visually change stuff. Maybe in future we might have some node, but what you will be doing is you'll be dealing with these numbers. So you'll simply have a transform node. In this vector, you'll try to move things with the numbers. Initially, it will look a bit difficult to try to visualize things in your head first and then putting it out in the numbers, but it gets really easy after a few attempts. So don't worry about it too much. So by the time we are done with a few more exercises, I think you will get a hang of it, and you'll start understanding how simple these numbers and how powerful these actually are when combined with this kind of interface. So first, I'm just going to bring a simple cube to explain a very simple thing. So let's say if we were animating this cube, I'll hit I, set a key and move this up, maybe 5 and something like this. So let's make this 100 frame animation. So our cube is basically moving up. Let's say if we had a duplicate of this cube, the original cube. So now we have 2 cubes. This cube right now doesn't have any animation. if I wanted this cube to have opposite animation of whatever movement is happening in this one, then what I would need to do is simply transfer whatever animation is happening in this transform node into this transform node and do some math so that the invert values, the negative values of the same amount are inserted into these slots. Let's say if this cube is moving 5 meters, then this needs to move minus 5 meters. And that will make a simple animation, two cubes moving in opposite direction. But right now we are manually setting the keys, and that is not really an ideal way of working with the geometry nodes. There is no advantage in doing this. So I'll delete this node, and I'll delete this node as well. So instead of that, bring a transform to be able to use value which we insert here. So instead of directly putting a value here, what if we bring a simple number here and use this connection to drive this value, and same value we can use in the opposite node. All right. So this way we have this one value which is basically driving these both cubes like this and this. But since I already mentioned this is a vector input and this value is not really going to work accurately with these inputs. So first we need to bring in a simple converter which is combine XYZ, just like we have converters for different charges, cables, plugs and all sort of things in the real world. So to make things compatible, you do have converters. As you can see now, this float value can go into any of these XYZ float numbers, and these three floats are converted into a blue vector. So if I plug this here now and use this value into Z direction and make it 5. Let's say if I go to the frame number 0, make it 0, hit I, 100 frame, make it 5 meters, I. So we have animation. And now what I want is this cube to have move in the inward direction. So let's bring combine XYZ here as well and plug this into translation, and let's move it. Let's connect this to the same value that we have for the animation. So at this moment, both of the cubes are moving in the same direction, and since both of these cubes are overlapped precisely, we are not able to see the distinction between them. So if I rotate this one slightly, you can see there are two cubes. Now what I would like to do is move this cube in the opposite direction. So for that we need to do some math and convert whatever value is going in here, the opposite of that value should go in here. So this network, this little wire, we need to manipulate with the utilities and math. Since we are working with a float number, the gray values, we are bringing in this simple math node and plugging it here. So to convert this into invert value, what we usually do is multiply that thing with -1. Alright, so now if this cube is moving 5 meters in Z direction upwards, then this go into this math node, multiply with -1 and become -5, and then go into Z direction here. Alright, so now have this invert animation going on. Now one last thing, now you can do all sort of math further if you want to bring some more math into this. Let's say if I plug this here and amplify this value with 5. So whatever is the speed of this first cube, the second cube is going to move in the invert direction, and then multiply with 5. It's moving much faster now. Or you can also do one more thing. You can input the same value in the rotation as well. So this cube will not only move but rotate as well in the Z direction. So yeah, I mean, this is not the best example, but we are going to discuss a visually better example in a moment and make some good use of all of that math that we are discussing today. So what I have here is a beautiful model which I downloaded from Polyheaven, and this particular model is provided by Rico Celiers, and I have worked with him before on plenty of projects, and I'm really proud of his work, whatever he have contributed in my projects as well. So just do check out his channel, especially to do with characters and sculpting and texturing. So the link is in the description for both the model, the Polyheaven, and the Rico Celiers, the artist profile, if you wish to download this model. Now what we are going to do is we have these 3 pins which are basically moving just like how a clock works. But since there is a relation between these three objects, second pin moves every second and the minute pin moves 60 times slower than the second pin, and the R pin moves 60 times slower than this minute pin. So we are going to do simple math to make this animation. So I'll delete this network that I have and bring back the objects that were there originally. So just to clarify a few things, when you download this model, all of that geometry is going to be one single object. So you might will have to extract these pins manually and set the pivot point to the center, and I'm pretty sure you must be aware of it by now. If not, then you can always go back to the chapter number 1 of basic introduction series and clear things out. I'll select the second pin. You can choose any pin on whichever you would like to make animation on. In the hierarchy, I think this is a good point to start with. So I'll select the second pin and click a new network and call this one clock animation. Let's bring a transform node. What we need to do is turn this 360 degrees, a pretty simple thing. So for that, we are going to bring in a value, and since this is a float and this is a vector, we are going to do the same thing. Go to the vector, combine XYZ so that we have access to these three float numbers here, and then plug this one into Y direction. And let's try to turn this 360 degrees. But you'll see something strange is happening here. When I was dealing with this here, you can see there's a degree sign here. So when I was working, things were working precisely, and in 360 it was coming out complete round loop. But here there is a no degree symbol. So when I try to turn this, I mean, it's not really working. It's supposed to. So I did a bit of research about this. Turns out this value, so for this to work, we would need to convert this into radians. So if we were turning this into 360, so 360 degree is 6.28 radian, and that is what we need, 6.28 something radian. All right, our animation is running at 30 fps. If animation is running on 30 fps and 60 seconds animation we are going to make to complete a 1 minute loop, so that will bring us to 1800 frames. So we already have timeline set to 1800 frames. So now our radian 6.28319 is the radian value, which is going to give us a 360 animation, needs to be divided by 1800. So on every frame we need to have this much rotation going on. All right, so instead of setting value manually with I and trying to rotate this one, what we will do is we'll bring in a simple expression. Simply type hash type frame. And what this does is it brings in a simple driver for whatever frame the animation header is running on. Let's say this is on 208, and that value will be inserted here. So what this gives us is a running number. We can tweak this further by multiplying it, dividing it. We can do all sort of things. So we have this running number, and this running number we are going to multiply with the value that we just brought out from calculation, a very basic math we did. 0.003 on every frame this the second pin needs to turn, and that is what we are getting here now. And let's plug this one here in the Y direction, and now we have accurate animation going on. Now let's bring a join geometry node, and let's bring in another node called object info. So what this node does is anything from your scene you want to pick up and include in this network, you can do that with object info node. So I'll select the R pin that we have here and minute pin. So second pin, minute pin, and R pin. And then I'll hide the original geometry, otherwise it's going to give us duplicates. Since these are already part of this network, there's no need for these original meshes to be in the scene. Let's add motion to these pins as well. So we are going to do the same thing, bring a transform node and bring a transform node. And these needs to turn in the Y direction and Y direction. And for that, again, we need to convert this into, sorry, I'll just hide this first and sort this out like this. So let's plug this one into rotation, plug this one into rotation. So we have converters going on, transformation going on, and all we need to do is in the Y direction, just plug a number. So let's plug this number that we have. the same number into the minute pin. So now the minute pin and the second pin both are moving in the same speed. I'm going to bring up float math, simple utilities math, and plug this in here. Multiply this with 1 divided by 60. That's because the minute pin moves 60 times slower, because in every minute there are 60 seconds. Simple thing. So now you'll see, if you zoom in a little, the minute pin is moving in 60 times slower than this second pin. So as soon as we have a minute animation completed, this is going to shift a minute further. So similarly, the R pin we have needs to be 60 times slower than the minute pin, all right, not the second pin. So instead of bringing in this value that we have inserted in the minute pin, we are going to take this value this time, which is already 60 times slower, and make it even more slower. 1 divided by 60, and that will make it behave like an R pin. So after 60 minutes, it's going to complete an R. And since the motion is so subtle, it would be really difficult to see actually some change going on here unless we wait for an hour here. All right. So just to give you a visual clarity, what I will do is Shift F and reroute this, plug another math node here, and speed up entire animation by 50. So now our clock is not running real time, but it's much faster. So you should be able to see our animation going on for the R pin as well. So let's make it 500 times faster. All of these, the ratio of all these three pins is working perfectly. So let's get rid of this. So one last thing I would like to do in this second spin, I don't want this to move gradually. Instead of this, I would want that snap animation that typically happens in the clock. So snap on this first, snap on the next second first. So go to the utilities math, and whatever value that we are inserting in second spin, right before that, we are going to plug in this math, change this to quite literally a snap math. So now we need to define an increment value here, like after how much value it should snap to the next second. So let's go back to the math that we worked on. A simple radian, every minute the second spin turns 6.2 radians. That divided by 60, this much radian is for 1 second. So here we are going to paste the same value. So every time the value reaches 0.105, only then the second spin is going to move and snap to the next value. All right. So what this does is basically it's not going to give you a gradual change that was going on before. Instead of that, based on increment value of 0.105, it's going to wait till then, and as soon as it reaches this threshold, it's going to snap to the next value. So all of these math nodes, the snap, and then all of these different comparison functions, rounding, trigonometric, can give you different results depending on different situations. So let's say if you're working on a texture, then snap would mean something else. I mean, it's a term that is used in math, but for visual purpose, for motion purpose, the possibilities these can bring out are endless possibilities, what these can bring out. But at the end of the day, all of these are values based on different functions. You can change the behavior of things, how they move, how they look. And if you understand math here, or if you are already familiar with the math from the shader editor, then you won't have to relearn it. It works exactly the same in both the editors, or I think for any other editor that will come in Blender in the future. It's only one time you need to invest in learning, and it's going to work exactly the same for even in the compositor, shader editor. So now that we have this pretty looking animation, so have fun with it, make a nice render out of it if you'd like, or if you have your own, you can animate that as well. You can also use some mechanical animation like a piston moving, I mean, just think harder. There are plenty of visual examples on Pinterest and Instagram. Have fun with it. Just try to understand the meaning of the different kind of values, inputs, outputs, and the compatibility and all that, and try to practice it a few times. Make few more things other than this example, so that for whatever examples that we are going to discuss in the future, you won't really have to struggle with the basic concepts of combining XYZ, using converters and using float numbers and the vector numbers and all that. So this was animation example. Now what if we use the math to change the shape of an object? And that is what we are going to discuss in the next chapter. So let's jump to the next chapter, click right here, and we are going to talk about how we can create an organic mesh by changing the position of these different vertices with the math nodes and all that. So I'll see you guys in the next chapter, and I hope you find this useful. If not, just give it some time, try to take it slow. It might not be the most intuitive interface, but once you understand it, you will feel really powerful, and you might be able to explore completely different ways of how you usually were dealing with your daily works. All right, so let's find out more about math in the next chapter. I'll see you guys there.